John with Lesson 1, an Introduction to AC for Year 13 Physics. So an electric generator consists of a coil that is spinning in a magnetic field with an angular frequency omega, and it produces an alternating voltage. So you would have done this in your electromagnetism chapter. So if you draw a graph of voltage against time, you're going to get a sine curve, and this maximum voltage, the peaks are called V peak or V max. Now the voltage at any instant is given by V equals V max sine omega t. And how do you get maximum voltage? It depends on a few things. It depends on the magnetic field strength or flux density, the area of the coil, and the number of turns of the coil, and how quickly is that coil spinning. So in a circuit, this alternating voltage produces an alternating current. So if you pass this alternating voltage, so this is the symbol for an AC supply, and it goes through a circuit, then you have a current, and the size of the current is given by V over R, and that graph will also be a sine curve, and you have your I peak or I max. Now both the current and the voltage, the electrons are going back and forth in simple harmonic motion for AC. Now since both the voltage time and the current time graph are sinusoidal, they have equal amounts above and below the x-axis, so they average out to 0. A DC meter will measure 0 voltage and 0 current. But if you draw a graph of power against time, because power is voltage times current, a graph of power against time will not have any negative values, because when you multiply a negative by a negative, you get a positive number. So the average power, so this is called peak power on the top, that's your average power. Your average power is actually half peak power. And the important thing about DC and AC, in a DC circuit, your positive and negative are fixed. The long lines are positive and the short lines negative, and the current only flows one way. But in an AC circuit, you have the current going back and forth in simple harmonic motion, so it's flowing both ways. Now, one way of averaging out the values is by using root mean square, and so we go with, so the root mean square value of an alternating voltage or current is the DC value that produces the same heat energy or the same power output. Now power is V times I, so your average power is actually half peak power. Your average power is V times I, but RMS values is half V peak times I peak. Now there are too many unknowns here, so let's substitute V equals IR. So when you substitute this V for I times R, there's already an I there, so you get I squared, I RMS squared times R equals half I peak squared times R, or you get I RMS squared is half I peak squared, or I RMS is I peak over root 2, or V RMS similarly is V peak over root 2. If you're asked to calculate power, you should always only use RMS values, never peak values. You can use Ohm's law, V equals IR, when there's a resistor in an AC circuit, but you never mix up peak and RMS value. Your V and your I both have to be either RMS or both have to be either peak value.